Have you ever stopped to think about this? If our natural resources are rapidly running out, why on earth haven't their prices absolutely skyrocketed? It's a core mystery, and honestly, it completely defies common sense, right? I mean, intuition tells us that as something depletes, it gets scarce, and because it's scarce, it should become practically unaffordable. But, as you'll see, history tells us a very different story.
Welcome to The Explainer. Today, we're diving into resource depletion and the regulation paradox. We're going to take a fascinating journey into the surprising and honestly totally counterintuitive gap between textbook economic theories and actual corporate behavior. We're going to explore exactly why the old models failed, how resources are actually managed across borders, and a truly mind-bending paradox about how corporations really feel about strict environmental regulations. Let's get into it.
Section 1. The exhaustion assumption. To understand where we are today, we first need to look at how we used to think about the future. Back in the 1970s, models like the famous limits to growth projected these severe, world-altering shortages of key raw materials. The assumption was simple: resources are finite, and we are definitely going to exhaust them.
So let's dive into this foundational concept that basically shaped decades of economic forecasting. It's called Hotelling's rule, formulated way back in 1931. It assumes that rational operators will only extract a resource if its price growth matches standard interest rates. Think about it like this. If oil or coal sitting in the ground isn't gaining value as fast as money sitting in a bank, a rational operator would just leave it in the dirt, right? Because of this, prices just had to rise exponentially. It's elegant math. But, well, there was a tiny problem.
Despite that pristine textbook math, the real price of a barrel of oil hovered around a virtually constant $20 from the early 1900s right up until the 1970s oil crisis. Just think about that for a second. For over half a century, the price essentially flatlined. The models predicted this steady, inevitable climb, but reality just delivered a flat $20.
Section 2. Reality breaks the rules. So why exactly do these models fail? How did the messy empirical data completely shatter these neat academic assumptions? This really hits the nail on the head when it comes to why theoretical frameworks often fail. Hotelling's model kind of existed in a vacuum. It assumed we had perfect knowledge of exactly how much resource was left, that there was just a single mine, and that costs were completely static. But, as we all know, the real world is incredibly messy. These theoretical models failed because they completely ignored human innovation. They ignored our uncanny ability to discover hidden reserves, our rapid advances in extraction tech, and the complex, constantly fluctuating costs of global transport. Which brings us to a rather dark but absolutely illuminating insight. As researcher Ivor Ekeland wrote it about the whaling industry, and this is a direct quote, "Money simply worked more efficiently than whales reproduced." It's wild to think about, but contrary to our intuition, a private company might actually find it far more profitable to entirely wipe out a resource, take that massive lump sum of cash, and just invest it in the stock market rather than sustainably conserve it. Basically, if the financial return outpaces the natural reproduction rate, the market literally incentivizes extinction. Section 3. Shared resources and the modern dilemma. The crucial takeaway here is that outdated, oversimplified models lead to bad policies. And that is incredibly dangerous when we're dealing with the messy reality of modern resource management, especially when those resources don't respect lines drawn on a map. So, let's look at our modern dilemma. Today, regulators are mostly dealing with what we call common property resources, or CPRs. These are resources shared between sovereign nations. Think of the Aral Sea between Uzbekistan and Kazakhstan, or the Upper Paraná Atlantic Forest spanning Brazil, Argentina, and Paraguay. Because they're shared, extraction by one country directly and immediately harms the other. It's basically like sharing a single milkshake with two straws.
This means regulators aren't just fighting one battle. They actually have to balance two massive external threats at the exact same time. First, you have the classic tragedy of the commons, where everyone rushes in to extract as much as possible, leading to rapid exhaustion. And second, there's the transboundary environmental damage. That's the actual physical, ecological destruction left in the wake of that extraction, which just spills right over the border into the neighboring country.
Now we enter the final, and honestly, the most fascinating act. Section 4, the regulation paradox. How do governments actually attempt to regulate these shared environmental disasters? And, maybe more importantly, how do the extracting corporations react to all this? We can actually boil these really complex economic game theory models down to a simple two-step dance. Step 1, the regulators look at the environmental damage and set a policy. That's either taxing extraction or subsidizing it to reach an efficient level. Step 2, the firms look at that policy and then choose their production levels purely to maximize their own profit. It's this continuous, high-stakes push and pull dynamic between national policymakers and corporate producers. Now, notice how this maps the exact tipping point. It shows exactly when a government will choose to subsidize an industry versus when it'll enforce strict taxes, all based on the extraction rate and the level of environmental damage. When extraction and damage are low, governments actually subsidize to stimulate production. But as that damage scales up, they're forced to cross that line and implement some really heavy taxes. But, of course, there's a catch. How governments regulate depends entirely on whether they're playing nice with their neighbors. Under non-cooperative regulation, a country only looks at its own domestic damage, which usually results in much laxer policies. But under cooperative regulation, like a big international environmental agreement, countries actually work together. Because they're now accounting for the transboundary damage hitting their neighbor, the resulting cooperative taxes are significantly stricter. And here's the twist. If you look at the top shaded region here, common sense says firms would absolutely hate strict international agreements, right? No way would they want more taxes. But the math reveals something crazy. When extraction rates and environmental damages are incredibly high, firms actually prefer the strictest cooperative taxes. They will literally support international environmental agreements that heavily tax them. Mind-blowing, right?
So how is that even possible? Well, regulation basically has two effects. Yes, there's a negative effect. Higher unit costs because they have to pay the tax, but there's also a massive positive effect for the firm. In a highly damaging, high extraction scenario, the industry is overproducing, which floods the market and drives prices down. The strict international tax acts as a forced mechanism to stop the entire industry from overproducing. By forcing everyone to cut back, market prices go up, and the firm's profits stay artificially high. They're literally using the regulation to save themselves from their own overproduction. Which leaves us with a pretty profound realization. From Hotelling's flatline predictions to firms secretly loving strict taxes just to boost their own profits, reality rarely matches the textbook. So I want to leave you with this question. If our foundational models are this flawed and corporate incentives are this paradoxical, are our modern environmental policies actually built on solid ground? Or are we just regulating for a world that economists merely imagined? Thanks for joining me on this explainer, and keep questioning the consensus.